And so, you know, I treat people who have post-traumatic disorder or symptoms of post-traumatic disorder. And so let's say they got post-traumatic stress disorder because, again, because a relationship collapsed on them suddenly, which is quite common. You know, they get betrayed or someone leaves them suddenly, and then they don't know what to do, because, especially if they're conscientious, because then they just tear themselves into pieces trying to figure out what they did wrong to bring about that event. And the reason they're doing that is because they want to retool their perceptions and their actions so that the probability that they'll have the same experience again is minimized. And their mind won't leave them alone till they do it. And no wonder, right? Because if you fall into a big pit and you get really hurt, the first thing you should figure out is how to not fall into big pits anymore. And your mind is set up exactly for that. And so what you do with someone who's having problems like that, so maybe they're waking up at the middle of the night obsessing about what went wrong, is you walk them through it. You do a situational analysis first, because one of the oversimplifications that people make, and this is especially true for conscientious people, is if something bad happened to me, I must have done something to deserve it. Now that's actually a pretty functional idea, because it suggests that there are things about your behavior that you could change that would make the future better. But the problem is that, say if it's the collapse of a relationship and you've been with that person for 8 years or longer, well, you did so many things with them that the idea that you did something wrong pretty much extends to every single thing you ever did with them. And that's, how are you going to fix that? And so that's part of the trauma, actually. The trauma is 80 million snakes all at the same time. It's like, well, forget it. You don't have time to go through all that material. And so partly what you do is with people, and this is what you should do with yourself too, is you do a situational analysis. It's like, don't be assuming necessarily that the thing that happened to you only happened to you because of what you did or didn't do. There's all sorts of factors at play. So one of the things that sometimes I do with clients is, if they were in a relationship and I can get some reasonable personality information about both of them, I can point out where they were temperamentally incompatible. You know, like if you're a highly conscientious person and your partner is very, very low in conscientiousness, it's like, well, good luck to you two. How the hell are you ever going to work that out? Because you want everything to be exactly where it's supposed to be, and you're working all the time, and your partner could care less whether things were where they're supposed to be, and they're not going to work. And you can butt heads about that forever. The probability that you're going to shift it, you know, except to some minor degree, is very, very low. And so sometimes you end up with someone with whom you get along very well on one temperamental dimension, and you're an absolute catastrophe on the other 4. And the probability that you're going to be able to mediate a huge temperamental difference is extremely low. You wouldn't expect yourself to mediate a huge intellectual difference, right? You're going to make the other person smarter, or maybe you smarter, depending on who you're with. It's like, no, probably not. A bit, maybe. So you do a situational analysis. And so what you're trying to do is to extract out information from your past and your present that will enable you to conduct yourself properly into the future. And so that's another example of the pragmatic element of thought. Well then, within the brain itself, apart from the major subdivisions which we just described, there are minor subdivisions, and here's a bunch of them listed: the caudate nucleus, the cerebral cortex, the huge newest part of the brain that's about a square meter. If you unfold it, it's all folded up, and most of the processing occurs right on the surface. That's the idea anyways. The thalamus, that's a place where a lot of the information in the brain appears to be integrated. The cerebellum helps you with balance and the sequencing of complex motor activities. The hippocampus, that's the one we talked about before. One of the things that the hippocampus seems to do is compare your model of the world as it's unfolding with the model that you desire to be occurring, and then keeps track of mismatches. And if it detects a mismatch, then it disinhibits other emotional and motivational centers. And that's the beginning of your response to the unknown. So one of them is the hypothalamus. I'm going to concentrate on it for a bit. It's a little tiny part of the brain that's pretty much at the top of the spinal cord. See, it's really small compared to the rest of the brain. Now, it turns out that imagine this is a cat brain for a minute, and you take off the whole cat brain, except for the hypothalamus, which people do. You take off the whole cortex, for example, and then the cat's still alive if you do it carefully, but it doesn't have much of a brain, and so you might think, well, that cat would just do nothing, but cat's actually pretty functional if it's reduced just to its hypothalamus, and that's because the hypothalamus is an incredibly important part of the brain, and it provides what I would say constitute the major frames, the major psychological frames. And so like a decorticate cat can still eat and drink and regulate its body temperature and engage in defensive aggression, and if it's female it can still mate. Male can't, because the male mating behavior is more complicated, and as long as you keep it in a bounded environment it can function reasonably well. It's hyper curious though, which is very weird, because you wouldn't expect a cat with no brain to be curious about anything, but a cat with no brain is curious about everything, and that seems to be because part of the reason that you aren't curious about something anymore is because you've investigated it and you've built a representation of it that's functional, and that functional representation then stands for the thing itself, and then you can ignore it, and so you learn to ignore things. They're interesting to begin with, and then you learn to ignore them. And so one of the things that I think artists do, if they're great artists, is remind you that there's more to things than you see now that you've learned to ignore them. So you get a kind of a hallucinogenic painting of flowers like Van Gogh might produce, like his famous irises, which I think sold for like $220 million or something outrageous. It's like what Van Gogh is trying to show you is what those flowers looked like before you thought you could see them, because now you flower and you walk by, you know. You don't see it at all because you're off to get a peanut butter sandwich or something. You don't have time to glory in the wonder of the world, you know. You've got something practical to do. So, all right, so we're going to zoom in on the hypothalamus here. And what you see, of course, when you zoom in on the hypothalamus is that it's not a thing. It's a whole bunch of things, and then it's one of those horrible whole bunches of things that are made out of even more bunches of things, and they're made out of more bunches of things. And what's really interesting about going down the body from an analytic perspective is it doesn't seem to get less complex as you go farther down, you know. Like some of the, I should actually show you that. I haven't showed you that little video of DNA fixing itself, eh? Oh, I better show you that. It's so cool. It's ridiculously cool, so you definitely need to see it. So like that's just so ridiculously mind-blowing that it's almost unbearable. I mean, to think about that as clockwork even is a pretty strange idea, because, well, those little things walk over obstacles. It's like, how the hell does that happen? They're just molecules. So it's so cool, because when you go down you'd think simple, but you know. And you know, he said at the beginning when they were taking that, when the little machines were taking that DNA apart, that he didn't show the error correcting. You know, there's other little machines that go along and see if everything's okay, and if it isn't, they cut it out and put a right piece in. It's like, yeah, things we don't understand. There's no shortage of them, that's for sure. Okay, so what I'm doing in some sense is walking you through a psychophysiological or representation of Piaget's developmental process, I would say. So I wanted to zero in on the hypothalamus because it seems to me the thing that sets the most basic frames. And so we'll go ahead with that. So you see that it's made up of all these little parts. And so it's called the hypothalamus more for convenience than because it's a homogeneous set of structures, because it's not a homogeneous set of structures. And this is something to consider very carefully when you're thinking about the terminology that psychologists use, or that you might use to describe your own behavior. Because you know, you can roughly, there is a psychology of motivation and there's a psychology of emotion, and you might think, well, emotion and motivation are categorically different entities, but they're not. In fact, there's no such thing as a uniform set of motivations, and there's no such thing as a uniform set of emotions, and the distinction between a motivation and an emotion is unclear, to say the least. And that's partly because the physiological substructures that subsume what we call motivations and what we call emotions, and it's not like there's a motivation center that's homogeneous. The closest is the hypothalamus, but it's made of structures that are qualitatively different. And then the emotions, because I have to use that descriptive terminology because we have to communicate about it somehow. There's all sorts of different structures in the brain that contribute to emotional expression, and they're not even in the same place, much less composed of identical structure or function. So we have these shorthands that we use to divide up the world, but they're awkward and untenable as the level of resolution increases. But anyways, I'm still going to go with motivation and emotion because it's a useful simplification. But you can see with the hypothalamus that there's all these complicated little subsystems in there. And then I showed you that video to show you just how complicated the subsystems are, all the way down to the molecular level. How those little machines manage what they do is completely beyond me. To call it clockwork when those little things that walk can walk over obstacles. It's like clockwork does one thing, only. Click, 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 click. That's all it does. No exceptions. This thing walks over obstacles to get where it's going. It's like, who knows what's going on down there. But it works well enough, so here we are, weirdly enough.